Hello everyone, welcome, Assalamu alaikum. Welcome to today's session. Just waiting for a few more people to join. Konnichiwa, guten Abend, hello. So today we are going through probability tree diagrams and we're looking at foundation questions. So there are 6 questions. The first one we are looking at is paper 1, so it's a non-calculator paper question from June 2023. Press pause and have a go. When you are ready, press play for the answer. Right, let's go through the question. So question 31, so it's towards the end of the paper. The probability tree diagram shows the probabilities that Shayla will work at home or will work at the office on 2 days next week. So we've got Monday and we've got Friday. We've got home, office, home, office, home, office. For Monday, working from home is 0.2 and it's 0.8 on from office. On the Friday, it's 0.7 for home and 0.3 for office, and the same thing here. Work out the probability that Shayla will work at home on Monday and work at the office on Friday. So this is what we call a kind of routine question. So if I highlight the keywords here, I've got all of this information. Really, because all the information is given to us, I don't really need to worry about this information. The probability tree diagram shows the probabilities that Shayla will work at home or will work at the office. So in a way, I don't even need to worry about this information here. So really what I'm focusing on is this sentence. Work out the probability that Shayla will work at home on Monday. So we're looking at home on Monday and work at the office on Friday. So we are looking at home and office. So how do we answer this question? So step 1 is we look at all the different outcomes that we can have. So step 1 are the outcomes. So I've got home, 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 office, office, home, office, office. So those are my 4 outcomes. And I'm looking for the probability that Shayla will work at home on Monday and the office. So home and office. So home and office is this one here. So what I need to do is I'm going to be multiplying. I'm going along this one and along this one here. So what I'm going to be doing is multiplying these two together. So it's 0.2 times 0.3. 0.2 times 0.3. Okay, so I'm working with decimals here, so I'm going to ignore the decimals. I'm just going to do 2 times 3. 2 times 3 gives me 6. And now I just add the place values in here. I've got 1 place value and a 2nd place value. So 1 place value and a 2nd place value, so it's 0.06. So that's my final answer, 0.06. Okay, and this question is worth 2 marks. Okay, so here's an analysis of all of the probability tree questions that have appeared in Foundation. So you can see it's appeared in paper 1, a non-calculator paper. It's also appeared in paper 2 and paper 3. So this topic is both calculator and non-calculator. So we need to be prepared for that. Here is the next question. This is the second question. This is from paper 3, June 2018. Press pause and have a go. When you are ready, press play for the answer, or when you're stuck, press play. Okay, so question 22, when a bias 6-sided dice is thrown once, the probability that it will land on 4 is 0.65. The bias dice is thrown twice. Amir draws this probability tree diagram. The diagram is not correct. So I've got the first throw, land on 4, not land on 4. Second throw, land on 4, not land on 4. Write down 2 things that are wrong with the probability tree diagram. So we've got 2 things here, 2 possible answers. So let me highlight key information first of all. When a bias 6-sided dice is thrown once, the probability it will land on 4 is 0.65. The bias dice is thrown twice. Amir draws this probability tree diagram. The diagram is not correct. So I need to look at my diagrams and see whether they match the information. So let's look at this. So when a bias 6-sided dice is thrown once, the probability it will land on 4 is 0.65. So what is the probability that it will not land on 4? Not land on 4 is going to be 1 take away 0.65. Okay, it's a non-calculator paper. It's a paper 3, so it's a calculator paper. I can just get my calculator out and I can just put that into the calculator. 1 take away 0.65 gives me 0.35. So that's my answer here, 0.35. Now I need to check whether that matches. So I've got 0.65 here, which is correct. And here, 0.25. That doesn't match. Okay, so I have to write this in words here. Write down 2 things. So the first thing is, on the first throw, the probability it will not land on 4 is incorrect. It should be 0.35, not 0.25. Okay, so that's my first thing I've done. Okay, let me go back and process the information. When a bias 6-sided dice is thrown once, the probability that it will land on 4 is 0.65. The bias dice is thrown twice. Amir draws the probability tree diagram. Now I'm looking at the second one, so I'm assuming it's the same information. So for the first throw, it should be 0.65. And you can see this is not 0.65. And on not landing on 4, it should be 0.35. And so you can see this is the wrong way round. If we look at this one here, 0.65, that's correct. And this one is 0.35, that is correct. So the top part of this should be the other way round. Okay, so I can write this in words. For the second throw, the top tree should be 0.65 for land on 4 and 0.35 for not land on 4. Okay, so it's a bit of literacy on this question. I hope you got that right. You can send me a message on chat whether you've got the correct answer. Well done if you have. Let's go to the next question. Here's a little quote for you. I came across this. I thought that I'd share this. A diamond is just a piece of coal that kept going under pressure. So during these exams, sometimes you're revising, it's very stressful. So just keep on going and just remember that a diamond is just a piece of coal that kept going under pressure. Here is question 3. Press pause and have a go, or if you're and when you're ready, press play. If you're stuck, you can also press play. This is from paper 1, so it's a non-calculator paper from November 2018. Have a go. Okay, I'm going to make a start. Press pause if you're still answering. So we have question 27. Amina has 2 bags. In the first bag, there are 3 red balls and 7 green balls. In the second bag, there are 5 red balls and 4 green balls. Amina takes at random a ball from the first bag. She then takes at random a ball from the second bag. Complete the probability tree diagram. First bag, we've got red and green. There's information for red, but for green it's missing. So that's one thing I need to work out. For the second bag, the probability of red is 5/9. This is missing. For red and green, these are also missing. And part B, work out the probability that Amina takes 2 red balls. Okay, and this is 2 marks for part B as well. So 2 marks there. Okay, let's go through this. First of all, Amina has 2 bags. That sentence we don't really need, so let's just cross that out. Okay, in the first bag, there are 3 red balls and 7 green balls. So for the first bag, let me just highlight this just to make it clear. First bag, we've got 3 red and 7 green. So if we have 3 red balls, R, and we've got 7 green, 1, 2, 3, 4, 5, 6, 7. We can see we've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 balls altogether. And so now you can see I've got 3 out of 10 for red, and for green, I'm going to have 7 out of 10. So this is going to be 7 out of 10. Okay, so I hope you got that right. Now let's go on to the second bag. In the second bag, there are 5 red balls and 4 green balls. So we can do the same thing again. We've got 1 red, 2 red, 3 red, 4 red, 5 red, and we've got 1 green, 2 green, 3 green, 4 greens. So altogether, I've got 1, 2, 3, 4, 5, 6, 7, 8, 9. You could just add them together as well. 5 plus 4 gives you 9. Okay, I'm just highlighting different ways to do this. So now that I've got that, I can see I've got 5 out of 9 for red. And I've got 1, 2, 3, 4 out of 9 for green. So 4 out of 9. And the same thing goes here. So I'm just going to repeat what's above there, below there. 5 out of 9 and 4 out of 9. Okay, so I've got that information done. Okay, work out the probability that Amina takes 2 red balls. So I'm looking for 2 red balls. So normally I go through my probability tree, then I look at my outcomes. So this is my red, 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 green, 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 and green, red rather, green, red, and green, green. So those are my outcomes. So that was my step 1, my outcomes. And then step 2 is I find my probability outcomes. Step 2 is find a specific outcome. And you can see from the last question, I'm looking for 2 red balls, so that's RR. So RR is the first one here. And so all I'm going to be doing is I'm going to be using 3 out of 10, 5 out of 9. So I'm going to be multiplying them. 3 over 10 times 5 over 9. Okay, so I'm using fractions now. So top numbers are multiplied and bottom numbers are multiplied. Now you could simplify, but you don't need to worry about simplifying. 3 times 5 is 15. 10 times 9 is 90. And so that is my final answer. You don't need to simplify, so let's not do something extra and then make a silly mistake. So there's no need to do anything extra. So that is my final answer. Well done if you got the same answer. Let's now go to our fourth question. Okay, so this is question number 4. This is from paper 2, June 2022. As you can see, we've got part A and we've got part B, which is also worth 2 marks. And if you want a set of the questions, it's in the description of the video. So feel free to download and have a go. So press pause. When you are finished, press play for the answer, or if you're stuck, press play for the answer. Okay, let's go through this. Question 20. Lorena gets a train at the same time each morning to go to work. She gets a train at the same time each evening to come home. The probability tree diagram shows the probabilities of each train arriving late. Complete the probability tree diagram. So I've got late, not late, and this is blank. Train home. So the first one was train to work, now it's train home. Late, not late. I've got information here, but no information there. And similarly here. And then for a day that Lorena goes to work out the probability that the train to work and the train home will both arrive late. Okay, so let's go through this. Lorena gets a train at the same time each morning to go to work. She gets a train at the same time each evening to come home. The probability tree diagram shows probabilities of each train arriving late. So you've got late and not late. So we know that all probabilities add up to 1. So this missing box will be 1 take away 0.13. And so it's paper 2 exam. Paper 2, which means that I am allowed to use a calculator. So we can just put this in a calculator. 1 take away 0.13, that gives me 0.87. Okay, and now I do the same thing for the second part, which is the train home. So all probabilities add up to 1. 1 take away 0.06. Again, put that in my calculator. 1 take away 0.06 gives me 0.94. And the same thing goes underneath here, 0.94. Okay, so we've got that. So that's done. For a day that Lorena goes to work out the probability that the train to work and the train home will both arrive late. Both arrive late. So what I'm looking for is late and late. So similar to previous questions, step 1 is to find all the outcomes. And then step 2 is to find my specific outcome, probability of specific outcome. So here I've got late and late. I've got late, not late, late, not late. Got not late and late. And not late, not late. Okay, so I've got that. So that's step 1 done, all outcomes. Step 2 is probability of my specific outcome. and my specific outcome is late and late, which is the first one. Work out the probability that the train to work and the train home will both arrive late. So late and late. So I'm looking at these probabilities. I'm going to multiply them. So my working out becomes 0.13 times 0.06. Get my calculator out. 0.13 times 0.06. And that gives me 7. So that's saying, I'll write this out because my calculator is displaying it like that. 7.8 times 10 to the power minus 3. So that's the same as saying, so it depends on how your calculator, some calculators will give you the exact answer. It's given me some standard form number, so I have to work this out a little bit. 7.8, if I have a negative power, it's the same as divide by 10 to the power 3. So I'm doing 7.8 divided by 1,000. So I've got 3 place values, 1, 2, 3. Put my decimal point there, add the zeros. So I now have 0.0078 as my outcome. 0.0078 is my final answer. Okay, and I hope you got the same answer as well. The other way to check this is there'll be 4 2 place values here and another 2 place values there. So I could just do 13 times 6. 13 times 6 is 78. And then I can add my place values, which is 2 and 2, 4. 1, 2, 3, 4. So that's how we can do that in case it was a non-calculator or something like that. So well done if you got the same answer. So we're nearly finished with our pack for today. And if you are new to the channel, remember to subscribe. And if you're finding this useful, do share with your friends. Okay, let's go to question 5 out of the 6. This question is a paper 3 question from November 2022. And you can see the questions are getting harder from where we started to where we're going. So press pause, have a go. When you're done, or if you're stuck, press play for the answer. Okay, let's try this. So question 26, one weekend, the Keddy family is going to do a sports quiz and a music quiz. The probability that the family will win the sports quiz is 0.3. The probability that the family will win the music quiz is 0.35. A, complete the probability tree diagram. Sports quiz, win is 0.3. This is missing, do not win. Music quiz, we've got winning 0.35, but do not win is missing. Same with that one, we've got that and this is missing. Part B, work out the probability that the Keddy family will win both the sports quiz and the music quiz. Okay, so let's go through the key information. Let's highlight them as well. One weekend, the Keddy family is going to do a sports quiz and a music quiz. Really, we don't really need that information. So that's that sentence. So we can just cross that out. Even this sentence here, I don't need that. So I just need to process these 2 sentences. The probability that the family will win the sports quiz is 0.3. And you can see they match. The probability that the family will win the music quiz is 0.35, and that matches here. So I don't need to worry about anything there. So now I just need to remember, what do probabilities add up to? Again, it's the same fact. All probabilities add up to 1. So I do 1 take away 0.3 to work out this box. Again, this is paper 3. So it's a calculator paper. Get your calculator out and do that. Although this calculation doesn't require a calculator. You can do it in your head, which will probably be faster, 0.7. And now we can do the same thing here. This probability becomes, all probabilities add up to 1. So these two make 1, take away 0.35, gives me 1, take away 0.35, gives me 0.65. And so this goes here, and it also goes in here, 0.65. So that's complete. Part B, work out the probability that the Keddy family will win both the sports quiz and music quiz. So we've got win both. So we're looking at win-win. And so similar to the last questions, you can see a pattern emerging. They're very, very similar. So hopefully you're getting this correct without any of my help. So step 1 is I need to find out all the outcomes, and then step 2 is to find my specific outcome. Okay, so we've got, this is win-win. I'm looking for win-win. This is win, not win, win, do not win. This is do not win, win. And we've got do not win, do not win. So I've got 1 tick here. So similar to before, I'm going to be taking these probabilities, 0.3 and 0.35, and I multiply them. So get my calculator out, 0.3 times 0.35. That gives me 0.105. Hopefully you got the same. So nice marks there. And on to our final question for today. So if you are enjoying this session, make sure you subscribe to the channel and remember to like the video as well. So question 6, it's a paper 3 question. It's from paper 3, so it's a calculator paper, June 2020. Press pause and have a go. When you're ready, or if you're stuck, press play. Okay, question 27. Amanda has 2 fair 3-sided spinners. So we've got spinner A, spinner B, and you've got 1, 2, 3, 1, 2, 3. So they have the same numbers here. Amanda spins each spinner once. So she spins spinner A and spinner B. Complete the probability tree diagram. Spinner A lands on 2 blank, does not land on 2 blank. So this is harder than before. The previous questions, they gave us some information in terms of some of these were filled in, but on this occasion, this one is not filled in. So this is going to be slightly harder. Similarly for spinner B, lands on 2 is blank and does not land on 2 is blank. Lands on 2 is blank here, and this is also blank. So I've got to fill that out. And then part B, work out the probability that spinner A lands on 2 and spinner B does not land on 2. So again, slightly different from the previous questions. Again, worth 2 marks. Okay, so let's highlight our key information, which we don't really need on this occasion. We've got 2 spinners. So let me look at spinner A. And I'm looking at lands on 2. So how many 2s do I have? For spinner A, I have 1, 2 out of 1, 2, 3 options. So my probability for lands on 2 is going to be 1 out of 3. Does not land on 2. Well, there's 2 numbers that are not 2. So that's 2 out of 3. Let me look at spinner B now. Lands on 2. There's only 1 2 there. Okay, 1 2. So again, similar to before, it's 1 out of 3 here. And does not land is 2 out of 3. 2 out of 3. 1 out of 3. 2 out of 3. And the same thing I just repeat here. 1 out of 3. 2 out of 3. So hopefully you've done that quite quickly. You can see it's slightly different from the previous questions, but it's very, very similar. Part B, work out the probability that spinner A lands on 2, spinner B does not land on 2. So what we have is we're looking for 2 and does not land on 2. Okay, so like previous question, step 1, we write out all outcomes. And then step 2 is we find our specific outcome. Probability of specific outcome. And you can see this question is different from the previous ones. So step 1, lands on 2, lands on 2. So this is 2, 2. Lands on 2, does not land on 2. Does not land on 2, 2. Does not land, and then 2. Does not land on 2, does not land on 2. And now I'm looking for, which one am I looking for? I'm looking for 2 and D. 2D is this one here. So I'm not looking for the first one. I'm not looking for the third one. And I'm not looking for the last one. So I'm not looking for these, only this one here. And so similar to before, I am going to be multiplying along my branches. So this is going to be 1 out of 3 times by 2 out of 3. Okay, and so 1 times 2, numerators are multiplied, denominators are multiplied. 1 times 2 is 2, 3 times 3 is 9. So my final answer is 2 out of 9. So I hope you found this video useful. Subscribe to the channel. There will be another probability tree diagrams for higher questions in the future. So if you haven't, make sure you subscribe, and I'll see you at the next one. Take care, everybody. Assalamu alaikum. Goodbye. Auf Wiedersehen. Bye-bye.